Hi everyone, welcome back to ChemHelp ASAP. In this video, we will work through how to calculate percent composition. We'll work through several examples step by step. Let's go. The best way, I think, to illustrate how to calculate percent composition is to actually work through some problems. So let's work through some problems. Let's start with our definition. Percent composition is a compound's composition in terms of the masses of its elements. So we are going to work through two different examples. We're going to calculate the percent of oxygen and carbon monoxide and the percent of oxygen and carbon dioxide. So these compounds are obviously very simple, but the percent oxygen in each of these compounds is going to be very different. We're going to work through these examples step by step. Okay, so here we have step one. We're going to calculate the molar mass of the compound. So let's take carbon monoxide first. Carbon monoxide is one carbon and one oxygen. So we're taking 1 times the molar mass of carbon and 1 times the molar mass of oxygen. So we get a molar mass of 28.010 grams per mole. Let's do the same thing, but with carbon dioxide. Now with carbon dioxide, we obviously have 2 oxygens, so you'll notice there is a multiplier of 2 when we multiply by the molar mass of oxygen. This gives us a total molar mass of 44.0098 grams per mole. On to step 2. In step 2, we're going to calculate the molar mass of the element in question. Now for us, this is going to be oxygen. We're looking for the percent oxygen in each of these compounds. Now we do need to remember to multiply by how many of these atoms are present in the compound. So let me show you that mathematically. Starting with our carbon monoxide, we have 1 oxygen atom in carbon monoxide, so we just have a multiplier of 1 here, and then the molar mass of oxygen. So our total molar mass of oxygen is just 15.9994 grams per mole. Okay, but now let's take a look at carbon dioxide. Remember, carbon dioxide, you have 2 oxygens, so we have a multiplier of 2 here. So this is going to be 2 times the molar mass of oxygen, which gives us a total molar mass of 31.99888 grams per mole. Next, step 3. We are going to calculate the percent composition by dividing the molar mass of the element by the molar mass of the compound and multiplying by 100%. Let's still start with carbon monoxide. So we have the percent oxygen in carbon monoxide. We're going to take our molar mass of oxygen divided by our molar mass of carbon monoxide, and again multiply that by 100%. So we already have these numbers. We calculated them in step 1 and step 2. So I'm just plugging in our numbers from our previous steps right here, multiply by 100%, and my percent oxygen in carbon monoxide is 57.120%. Let's do the same thing for carbon dioxide. So here's my percent oxygen and carbon dioxide. Again, I'm going to take my molar mass of oxygen, that has a multiplier of 2, over my molar mass of carbon dioxide. Again, I have calculated both of these quantities in the previous step. So here is my molar mass of oxygen. Again, it's the 31.9988 because I had this multiplier of 2, over my molar mass of carbon dioxide, which is 44.0098. Again, multiply by 100%, and I get 72.7083%. The only thing I will add to this is when you add up the percent composition for all of the elements in your compound, you will get 100%. The temptation is to look at a compound like carbon monoxide and think, oh, that's 50% oxygen. The problem with that approach is it completely disregards the molar mass of the element and the molar mass of the compound. So don't fall for that trap. Make sure you're using the methods and the steps that we used to actually calculate percent composition. I hope this video helped, and thanks so much for watching.